In this video, I will walk you through some multiple choice questions taken from past AP exams pertaining to methods of integration. When the exponent in the denominator is 1 more than the numerator, usually it's just a matter of u-substitution. Let's let u equal the exponent, x to the third power. In that case, u prime will equal 3x squared. Let's do that substitution, and we get x squared over e to the u power. Instead of dx, we will write du over u prime, which is 3x squared. But then we notice that we have x squared in the numerator and in the denominator. So these will cancel each other out. The 3 in the denominator can be brought out in front of the integral as 1/3. So now we have 1/3 the integral of 1 over e to the u du. To be honest with you guys, I ran into a roadblock just now because this does not fit any of our integration rules. And I almost deleted this part and started over, but I wanted you to see how integration works. Sometimes you start with an idea for u-substitution and it doesn't work out and you have to go back and try something else. So learn from this process. Instead of letting u equal just the exponent, let's try letting u equal the entire denominator. So in this case, u will equal e to the x cubed power. Then u prime will equal, well, let's see, the derivative of e to the something is still e to the something. So I will start off with e to the x cubed power. However, we do need to do the chain rule and multiply by the derivative of this inner function. So I multiply by 3x squared. Let's go ahead and do this substitution and see what happens. Instead of writing dx, we will write du over u prime. But remember, u prime is e to the x cubed power times 3x squared. We see that we have x squared in the numerator and in the denominator. These will cancel each other out. However, the 3 in the denominator can be brought out to the front as a 1/3. So far, we have 1 over u e to the x cubed power du. For a split second, we are worried about this e to the x cubed power, which wouldn't fit any of our integral rules. However, we remember that u equals e to the x cubed power. So this expression is just another u. So we actually have 1/3 times the integral of 1 over u squared du. Let's rewrite 1 over u squared as u to the -2 power. So this will make it easier to apply the power rule of integration. Let's add 1 to this exponent. That will give us u to the -1 power. Then we divide by the new exponent. This will put a negative sign out in the front. I'm going to go ahead and bring down the 1/3 that we have, and I'll put that negative sign out in front. And then we have plus c. Let's substitute e to the x cubed power back in for u. The -1 exponent just reminds us to put e to the x cubed power back in the denominator. So we will have -1 over 3 e to the x cubed power plus c. So the correct answer is C. For number 2, I notice that the degree of the numerator and the degree of the denominator are exactly the same. So when that happens, we can't just do u substitution immediately. So what am I going to do? I look to see if I have a plus b over c. In other words, if I had x squared plus 1 over x squared, for example, I know that I could split this up into two fractions. I could put x squared over x squared plus 1 over x squared, and I would end up integrating each one of these separately. But that's not what we have. When the binomial is in the denominator, there is no easy way to split this apart. So what I need to do is long division. We are dividing x squared plus 1 into x squared. We start by focusing on the first term in each part. X squared times what will give us x squared? Well, that's just 1. So this is going to be a very short problem. We are already at the constant. Next, we take this number and we do the distributive property. 1 times x squared is x squared, and 1 times 1 is 1. But then we subtract. X squared minus x squared is 0, so we write nothing. 0 minus 1 is negative 1. This is the remainder. So we take this remainder, there's my negative sign, but I make a fraction out of the remainder. I put the remainder over the divisor. So I have 1 over x squared plus 1. This is equivalent to what is inside the integral. So let's rewrite the integral using this expression. I am going to purposefully take away the limits of integration for now, and I will bring them back in at the end of the problem. So here's my brand new integral. I think it will be easier if we split this up into two separate integrals. So I will rewrite this as the integral of 1 dx minus the integral of 1 over x squared plus 1 dx. This first one is trivial. The integral of 1 dx is just x. So that's done with. For the next one, this is actually going to be an inverse trig rule. We can see that the degree of the denominator beats the degree of the numerator by 2. That's how I know this is going to be an inverse trig rule. Here are the 3 inverse trig rules that you must memorize. The one that matches this problem is the arctangent rule. When you compare this integral to the rule, the x squared is the u squared, and the a squared is the 1. This means that the a value is going to be 1, which will always be the square root of the constant. And of course, the square root of 1 is 1. It doesn't matter that in the rule we have the constant plus the variable, and here we have the variable plus the constant, because addition is commutative, so the order doesn't matter. For subtraction, it would matter, but this is just fine. So let's go ahead and use this rule to integrate. So we see that we have 1 over a, but a is 1, so that's just 1 over 1, so we don't need to write that part of it. Let's move on to arctangent. So we write arctangent, and then u over a, in this case, would just be x over 1, which is just x, and then plus c. However, we suddenly remember that this is a definite integral. So instead of putting the plus c, we put a vertical line and apply the limits of integration. This reminds us that we need to find the value at 1 and then subtract the value at 0. So here is the value at 1 minus the value at 0. Let's evaluate. So we have 1 minus the arctangent of 1. This means the tangent of what angle is equal to 1, and that is pi over 4. So we have 1 minus pi over 4 minus, the 0 is not needed, so we have negative arctangent 0. Well, the tangent of what angle is 0? That would either be 0 or pi, but we need to consider the restrictions of inverse trig functions now. Arctangent is only defined between negative pi over 2 and positive pi over 2. So the answer will be 0 and not pi. Here are the other restrictions, just in case you need a quick reminder. Make notes as needed. So arctangent of 0 was 0. So we have a whole lot of 0 going on the right-hand side. Really, we just have 1 minus pi over 4. Let's check the answer choices and see if this shows up. As I scroll through the answer choices, I do not see 1 minus pi over 4. It's pretty easy to see which one is going to be the answer, but let's go ahead and combine this into one fraction so we can see how it matches one of these answer choices. To make like denominators, we will replace the number 1 with 4 over 4. So we have 4 over 4 minus pi over 4, which means that we have 4 minus pi over 4. Let's look again. Oh, look, there it is. So the answer is A. Number 3 involves an integration rule that I want you to memorize. The integral of tangent u du is negative natural log absolute value of cosine u plus c. So with that in mind, let's do u substitution and let u equal 2x. Well, I shouldn't just put that right there. Let me move this. I'll put it a little bit further away. So u is 2x, which means that u prime is 2. Let's go ahead and do the substitution. Instead of dx, we write du over u prime, which is 2. But this 2 can be put out in the front as a 1/2. So let's just do that immediately. So we have the 1/2. And now it's time for the memorized rule. So this integral is negative natural log absolute value cosine u plus c. So I have negative natural log absolute value of cosine u, which is 2x, plus c. Of course, we do have this 1/2, so I'm going to bring that right down. So this should be the integral. Let's compare that to our answer choices, and ding, ding, ding. The answer is B. Number 4, the area of the region bounded by the lines x equals 0, x equals 2, y equals 0, and the curve y equals e to the x over 2 power is which of these? I feel like a sketch is in order. X equals 0 and y equals 0 are just the x and y axis. X equals 2 is a vertical line at 2. And y equals e to the x over 2 power is this exponential growth curve shown here. So we are being asked to find the area of the region bounded by these 4 curves. In other words, we need to find the area of this yellow region. But this is just the area between the exponential curve and the x-axis from 0 to 2. So we can represent this as a definite integral. The integral from 0 to 2 of e to the x over 2 power dx. Let's do some quick u substitution. Let's let u equal x over 2. In that case, u prime will be 1/2. As I do the u substitution, I'm going to temporarily take away the limits of integration. I will bring them back at the end of the problem when we put the x's back in. So we have this, but instead of writing dx, we will write du divided by u prime, which is 1/2. However, dividing by 1/2 is the same as multiplying by 2. So I think I'll just do that immediately. And I will put that 2 out in the front of the integral. So this is an easy integral. The integral of e to the u is e to the u plus c. And we have the 2 that's out there. So we would have this. Let's replace the u with x over 2. And let's suddenly remember that this is a definite integral. So instead of putting the plus c, let's put a vertical line and reapply the limits of integration. So 0 to 2. This reminds us that we need to find the value at 2 minus the value at 0. So here's the value at 2 minus the value at 0. Of course, 2 divided by 2 is 1, so this is just going to be 2e. E to the 0 power is 1, so this will just be minus 2. I am glancing at the answer choices. I don't see this immediately, but I notice that one of the answer choices will be what we would get if we factor out the 2. So if I take that 2 outside of parentheses, we get 2 times e minus 1. So the correct answer is C. For number 5, I am going to get to use the a plus b over c rule. When I see something in this form, I can always split it up as 2 fractions by writing a over c plus b over c. So let's do that to this integral. So we have this. Let's go ahead and simplify each term. Well, for the first term, I get 1 over x. There isn't really anything I can do with the second term. However, I think I would like to bring the x squared out of the denominator and rewrite it with a negative exponent. And you'll see why I did that in a second. So for now, let me go ahead and write 4x to the negative 2 power. Integrating term by term, the integral of 1 over x is the natural log of the absolute value of x. For the next term, I'm going to use the power rule of integration, and that's why I rewrote it as x to the negative 2 power. So for the power rule of integration, we increase the exponent by 1. That will give me the negative 1 power. Then we divide by the new exponent. Dividing by negative 1 will change this negative 4 to a positive 4. And then we will have the plus c. Well, no, this is a definite integral, so we won't do that. Instead, we will put a vertical line and apply the limits of integration. Before we evaluate, let's go ahead and write 4x to the negative 1 power as 4 over x. Now, given our limits of integration, we need to find the value at 2 minus the value at 1. So here is the value at 2 minus the value at 1. Let's simplify this as much as we can. The natural log of 2 no longer needs the absolute value, so I can at least just write natural log 2. In fact, I don't think I'll even put parentheses. Let's keep it simple, people. Natural log of 2. And then 4 over 2 is 2, so we have this. The natural log of 1 is 0. That's something that you should just memorize. And 4 over 1, of course, is 4. By the way, the reason why the natural log of 1 is 0, because natural log means log, base e. And e to what power will give you 1? Well, that's 0. That's why the natural log of 1 is 0. That was just a quick side lesson. Anyway, back to this. 2 minus 4 is negative 2. So we end up with the natural log of 2 minus 2. That's as much as we can simplify, so let's take a look at the answer choices. And what do we have here? The correct answer is B. Last one. If dy dx equals sine x cosine squared x, and if y equals 0 when x equals pi over 2, what is the value of y when x is equal to 0? How do we usually find the value of y given a value of x? Normally, we plug the value of x into the original equation, and then we can find the value of y. But we don't have the original equation, we have this derivative expression. If only there was a way to turn this derivative back into the original equation. Well, that's called integration. So let's integrate both sides of this equation with respect to x. The integral of dy dx is just y. Now, what about the integral of sine x cosine squared x? I feel some u-substitution coming on. The u value is usually something that's inside of another function. So I see that cosine is being squared, so let's try letting u equal cosine x. In that case, u prime will equal negative sine x. So let's go ahead and do that substitution. So then y will equal the integral of sine x times u squared. Instead of dx, we will write du divided by u prime, which is negative sine x. We notice that we have sine x in the numerator and the denominator. We can take the negative sign in the denominator and put it out in the front of the integral. So we get y equals negative integral of u squared du. Let's use the power rule of integration. So we have u, and we increase the exponent by 1, so that will be u to the third power. And then we divide by the new exponent, so we get 1/3. Let's not forget about the negative sign in front, so we have this. And we have plus c. Putting cosine x back in for u, we have this. This equation won't be useful until we find the value of c. Fortunately, they gave us the initial conditions, which will allow us to find the actual value of c. Since y equals 0 when x equals pi over 2, we can simply substitute 0 for y and pi over 2 for x, and then we can solve for c. So we get this, and we have 0 equals negative 1/3. What is the cosine of pi over 2? The cosine of pi over 2 is 0. So now we have 0 to the third power, which is just 0, and 0 times negative 1/3 is 0. So we end up with c equals 0. That means the original equation must be y equals negative 1/3 cosine cubed x, and that's all. So now we should be able to use this equation to find the value of y when x is equal to 0. So substituting 0 for x, we have y equals negative 1/3 cosine cubed 0. What is the cosine of 0? Remember, cosine is the x value, so cosine of 0 is 1. So this will be negative 1/3 times 1 cubed, which of course is just 1. So y equals negative 1/3. So the correct answer is B.